For our experiment today, our class will be divided into two groups, the micro scale group and the small scale group. But for both of these, you will be using test tubes or reaction tubes, as is mentioned here, with boiling stones. When we have boiling stones, they create nucleation sites, and all the hot liquid that you will ever boil or heat, you will need to add the boiling stones in them. In one of the tubes, you will just have your impure benzoin, and in the other tube, you will have your ethanol, along with a pipette. Now, if you remember your IR lab, I mentioned no inverting pipettes, and that rule will still follow today. Especially that when you will invert your pipette, hot liquid will squirt out. Also, I do not want you to place the thermometer in the beaker. Otherwise, your beaker may topple off. You can periodically look at the temperature by inserting the thermometer in it and taking it out. Remember, do not place your hot thermometer on the bench, otherwise it will crack. So your first part is adding of solvent in this impure benzoin. How much do you have to add? This is decided by adding enough amount that it dissolves your solid. If you add too much of the solvent, some of the compound will stay back in the solution and you will have low recovery. But if you add too little of your solvent, not all of your starting material will dissolve, and which will carry the impurities in the solid itself. You will get a higher recovery, but your purity will decrease. So you always have to remember to add enough solvent to dissolve the solid. As soon as your solid is dissolved, you will stop adding the solvent. When you're cooling also, the cooling will also impact your recovery and purity. Ideally, we should cool it very slowly. When you cool it slowly, you give the molecules of the solid that you want to recrystallize some time to come together and form the crystals, which are usually large or longer crystals and pure crystals. But if you force cool it, for example, if you have a hot tube, a hot solution, and you plunge it into ice, you are immediately trying to cool your solution. You will trap impurities also within the crystallizing molecules in their crystal lattices, and hence you will get impure crystals. So how much solvent you add and how fast or slow your cooling is done will impact your recovery and your purity. And this is what your lab and the theory behind this lab and the questions on your exam will be primarily based upon. I have collected a few situations for you. For example, not all of the solid was dissolved in hot solvent. These situations you should think about in using all the practical information that we have listed in our previous discussion. What will be the impact on recovery? What will be the impact on purity? So if all the solid was not dissolved in the hot solvent, some of the solid will carry the impurities in it, and hence the purity will go down when you will recrystallize or you will collect your recrystallized material. Because of those impurities, your recovery will be higher than it should have been. So for example, if you have a material in which we have about 90% compound and 10% impurity, when you recrystallize this out, you expect 90% from the starting material. So if you started out with 1 gram, you expect to get 0.9 gram. This is what your expectation is. But if all the solid was not dissolved, you will get probably 0.93 grams of your recovered material, which will indicate that you have a higher than expected recovery, and definitely there are some impurities present in your compound. Similarly, if your capillary was filled to 1 centimeter in depth, this is where your melting point lab will help you. Usually, we allow up to 1 millimeter of material to be filled. If you fill too much material, it will take more time to melt, and your melting point range will be very high, more than 5 degrees Celsius, which will give you an impression that your purity is bad. Remember, melting points, the value should be close to the literature value, and your difference of the range should be narrow for the material to be identified and characterized as pure. So if you have unnecessary extra amount in your capillary, your purity will go down, but it will not have any impact on your recovery. So you may recover 0.90 grams of material, but having a melting point of somewhere around 128.3 to, let's say, 148.5, just because it took all this time to melt the extra material. So you should get familiar with these situations. Think about it in common sense terms. You will be given situations like these for your exam.